Hi guys, so this is the next part in section 4.1. This is a lesson on reciprocal functions. So basically, what is the graph of these inverse variation functions that we've been looking at and working with last lesson? What does the graph of a function look like? And what we call them are reciprocal functions. So what comes to mind when you hear the word reciprocal? Sometimes we think about a flip, right? You guys would probably say flip or opposite. It's not really opposite, but I don't mind this word flip. So for an example, if the reciprocal of 8 is 1 over 8. So whatever the fraction is, like we know a whole number, that's like always over 1. So 8 over 1, the reciprocal of 8 over 1 is 1 over 8. And why this is called the reciprocal function is because when we put values in for x, the output is the reciprocal. So let's take a look here. So when I put -3 in for x, -3, and then I'll have 1 over -3. That's the reciprocal of -3. All of these values are reciprocals to each other. When I put in 2, what I get out is 1 over 2. That's the reciprocal, just like 8 is 1 over 8. Same thing would happen here. And what happens when I put those values into the function, and then I get this table of points, and then I want to graph those points, the function graphs like this, okay? And so like you could say like 2, if I go up 2, the y value is 1/2. 3, the y value is 1 over 3. Okay, take a look at what happened at 0. When I put 0 in for x, it says 1 over 0. If you do that on a calculator really fast, it's going to say error, right? 1 divided by 0, I can't do that. That's why we get this answer of undefined. So notice this graph is getting really, really close to 0, to the x-axis and the y-axis, but is it ever crossing it? So will this orange line ever cross over the y-axis? Same thing with all these values. The answer is no. It's never going to be able to touch the x when x equals 0 and when y equals 0 because of that answer right there. When I put an x value in, I get an undefined answer. And what that's called, so there's something that this is called something. It's not just going to be x equals 0. It's called an asymptote. An asymptote is a line that a graph approaches. So notice that this orange line is going to get really, really close to the axis, but it's never going to touch. An asymptote guides the end behavior. It's a line that a graph will never cross. Okay? There are two types of asymptotes that we're going to talk about, horizontal and vertical asymptotes. Obviously, horizontal asymptotes would be a horizontal line. There's a horizontal asymptote. And a vertical would be a vertical line, right? There's a vertical asymptote. And we can take a look at the domain and range, which is something we haven't talked about back since chapter 1. But domain and range, remember, domain is a list of all our possible x values. So every single x value will be crossed except 0, right? It's never going to touch 0. So that's why my domain would be from -infinity, and then I touch 0, but then I skip over 0, and this is what that symbol means. It says and. So it goes from -infinity to 0. The parenthesis says it just gets close to 0. It doesn't actually touch 0. And then it picks back up on the other side of the 0 to positive infinity. The range is actually the exact same thing. Again, look at the y values. That's what range stands for, a list of all our possible y values. Every single y value will have a point on this graph except when y is 0, okay, which is why our range is this. If you need to make a note, domain is x values, range is y values. So why we're talking about this background information is because we're going to move on to graphing reciprocal functions. Before we graph reciprocal functions, let's talk about transformations for a second. So this is quadratics. This goes back to chapter 2. Let's just remember, when I have a number on the inside of the parent function, notice the 6 is on the inside of those parentheses, we move horizontally. And remember, it's the opposite of what we think. So minus, we think would go to the left, but it actually goes to the right. And the outside number, the 4, moves vertically, so that goes up 4. Okay, so that's just some notes to remember and kind of use when we go and graph reciprocal functions, because it's a very similar process. Okay, so this is the function that I want to graph now. I want to graph g of x equals 1 over x minus 3 plus 2. And I have to do a few things after I graph it. I have to figure out what the asymptotes are and what my domain and range is. So first what we're going to do is, so let's kind of connect here. Notice the plus 4 and the plus 2. They're both on the outside of the parent function. The parent function is 1 over x. This is my parent function. So because it's considered on the outside, that plus 2 I know moves vertically up 2. And the minus 3 on the inside moves horizontally, and it's the opposite of what we think, so right 3. And how those transformations, I need to figure out this first, because that's how I go down and move my asymptotes. Okay, so right now, this is the parent function that's graphed, and that's where the function starts. Just like think about a parabola before we move it, it starts at the origin. This is where the graph starts. And then I take the asymptotes and I move them these transformations. So up 2, I take my horizontal asymptote and move it up 2 units. Okay? Think about like if I took this one, like up 2, like it stays the same, right? So moving the vertical asymptote up 2 doesn't change it at all. So that's why we move the horizontal asymptote up 2, and then I take my vertical asymptote and I move it to the right 3. Okay, and now what we do is now I can draw my new g of x function, and I just draw those graphs. It's a rough sketch in the same parts of those asymptotes that the parent function is in. Okay, notice now we can cross the x and y axis, but I can't cross my dotted lines. That's what represents the horizontal asymptote. So now I can go ahead and talk about what's my horizontal asymptote. Well, I look for my horizontal line. I have a horizontal line right here. Whoops, right here. This red line, that's my horizontal asymptote when y equals 2. That's the answer. I have a vertical line when x equals, when x equals 3. Okay. And then my domain and range. So now my domain, remember, is all possible x values. So look at this purple graph. I know there's a lot going on, so just focus on the purple graph. All of these x values will be used, all of these x values, all of these x values. This purple graph is going to get really close to this x value, but never cross it. That x value is 3. And then it's going to hop over 3 and then continue on the other side. It's just never going to touch the x value of 3. Notice that's why we had an asymptote at 3. Okay, it's never going to touch it. That's why we have to skip over it in my domain. My range, similarly, skips over 2, right? Range is the y value. So looking at my y axis and the purple function vertically, so this y value would be used, this y value would be used. Good, good, good. What happens when I get to 2? It gets really close to 2, but it never touches. Then it skips over it, and then it continues increasing all the way up. Okay, it just skips over 2. Okay, and that's it, guys. We can take a look at another one if you want to practice. The minus 4 on the outside, we know moves down 4. Plus 2 on the inside, it's the opposite of what we think, so left 2. And then we do the exact same thing. I take my, if I'm moving to the left 2, I create a vertical asymptote, left 2. And I make my horizontal asymptote go down 4. And then I just draw the graph within those parts of the function, within the parts of the asymptote. It's always the upper right and the lower left. It's a rough sketch. Okay? And then I can go and identify my asymptote. So I have a horizontal line when y equals negative 4. I have a vertical line, a vertical asymptote when x equals negative 2. And my domain, the x values, skip over negative 2. And the y-axis, the y values skip over negative 4. Okay, and that's it. So that's what you guys are going to practice. I wanted to show you on, let me show you on Desmos really fast. Open up a new tab here. Okay, if I graph, so here's 1 over x. There's that function that we've been working with. But if I do 1 divided by x, let's do the one we just did, plus 2 minus 4. Oops. So there's the graph right here where I have and that's what it looks like. I'm just showing you this because there's a lot going on in the Smart Notebook page, but this is what it looks like. It starts it like this, and then I apply those transformations, taking it down 4 and to the left 2, and it turns into this function. Okay, awesome job, guys. You guys are going to practice graphing and identifying asymptotes and domain and range. You guys got this. Great job.